Example 169. Calculate the correlation coefficient for the following data set, which gives the waist measurement and body fat percentage for males who weigh 165 pounds. Do these quantities have a linear relationship? If so, is it positive or negative? Okay, so we have the data provided to us, right? And from there we need to use a formula. Now the formula that we're going to use for the correlation coefficient is going to be the formula for R, because that's what R represents, the correlation coefficient. So R is a pretty simple formula. It's the sum of squared value for the mixed term, xy, divided by the square root of the other two sum of squared calculations that we normally do. So SSXX and SSYY. So that is your R formula. So if you had these quantities, it would be quite easy to calculate. So what I've done for us, so we don't have to spend a huge amount of time, because we've done these before so many times, I've gone ahead and taken the data and done all that work for us. So let's go ahead and do that work right now, or basically show you what that work was when I finished it. Alright, so here is the results of my calculations. So remember what you have to do with the data. You take all the x values, you sum them up, you take all the y values, you sum them up. Once you get their sum, you square the x values, you add up all that, you square the y values, you add up all that. Then you multiply the x and the y columns together, producing this column, which you then sum as well. When you're done, you use the formulas that we've used before for these quantities, and you end up with the totals that I came up with. So at that point, all we need to do is to plug these numbers in. And so if your professor on the exam gives you these quantities, it's really, really simple to work with. If he gives you these quantities, it's still relatively easy. If he makes you do all the calculations, well, that's going to take you a long time, but it's not hard, it's just time consuming. Okay, so let's go ahead and put the numbers in then that we have from our work. So the mixed term, SSXY, that is 100, right? So the mixed term on top is 100. Then we will divide by the square root of, and by the way, just because this term already is positive, I can tell R will be positive. SSXY is responsible for giving you the sign of the R value. These guys are always positive, and when you take the square root of positive numbers, you still get positive answers. So the ultimate determinant in whether it's negative or positive is going to be SSXY. All right, now SSXX is 40, and then that'll be multiplied by 256.3. Okay, so we have our formula filled in. Let's see what that is after plugging it into our calculator. So we have 100 divided by the square root of, and the number there in the square root is 40 times 256.3. Close it up and hit enter, and you get the value 0.988 when round off to 3 places. So I'm going to make this an approximate symbol and go 0.988. So that is quite a R value. Remember, R ranges between 0 and 1, right? So let's talk about the interpretation now, and we'll go on to answer the last part of the question. When you look at the question, they talked about certain things here. They said, do the quantities have a linear relationship? So are these linear related? Well, if your R value is very close to 1, 1 is the absolute highest R could ever be. Its absolute smallest value is -1, so R ranges between -1 and 1. Now, at those two extremes, you have perfect positive correlation, which would be at the extreme of 1, right? And then at the extreme of -1, you have perfect negative correlation, right? So this would be perfect negative correlation, and this one would be perfect positive. Now, we should not get perfect positive or negative correlation. If we have that, then your equation is completely deterministic if you try to model these two using x and y in the linear regression model. And deterministic means there's no random error, which means that this is more like an algebra problem. So we should never see -1 and 1. But when you see numbers like this that are very close to 1 or very close to -1, that implies a strong linear relationship. And because it's a strong linear relationship, because it's so close to this perfect positive correlation value of 1, because it's positive, we will say that it's a strong positive linear relationship. So I would say here, basically we're coming up with the idea that it's a strong positive linear, right? So positive linear relationship. Linear relationship, LR. Alright, so since it's a strong positive linear relationship, then that tells us something. And what it tells us is that the two variables move in the same direction. So strong positive, if you saw a picture of it, it looks like this. It looks like as one variable increases, so does the other. That means if you're talking about the waist size being down here as the x-axis, and you're talking about the body fat percentage here, so body fat percentage on the other axis, it means as your waist size increases, your body fat goes up. That's what the strong positive linear relationship means. And linear just means the shape falls along a line, right? So the scatter plot kind of looks like a straight line. You can run a straight line through it and get a good relationship between those points. Alright, now at that point, what would negative relationship look like? Well, negative relationship looks like the other direction, going down, and that would mean that as one goes up, the other goes down. That would be a negative relationship. And then, of course, if it's a horizontal line, we're talking about no relationship. So let me just cover that quickly in a couple of drawings here. So this is the positive relationship, right? Positive relationship. Let's look what negative relationship would have looked like. Negative relationship would have looked like as waist increases, right? Then body fat decreases, right? So the body fat then would be dropping as the waist increases. And that would look like this. It would look like a line going downhill, right? A negative relationship. And then lastly, we would have the concept of no relationship, right? No linear relationship, I should say. Or basically, in this case, no relationship, which I'll draw a horizontal line. And this means that as one goes up and the other one doesn't change. So it essentially means that waist size would have nothing to do with body fat percentages. We know that's, of course, incorrect, right? But, the idea is just to convey the three different drawings that would represent positive relationship, negative relationship, no relationship. So the fact that this number is 0.988, it indicates a strong positive linear relationship. This is the idea we're talking about then. So it looks like basically as waist size increases, body fat increases. Now, again, waist size increasing is not the cause of the body fat increasing, right? In fact, the other way around, maybe, as body fat increases, your waist size probably increases. So it looks like Y actually causes X here, if you want to associate a causal relationship. Having said that, R does not give you causality. You cannot say just because the R value is high here, in this case a strong positive relationship is shown. That just means that these two variables tend to appear together, right? So in human beings, when your waist size is bigger, your body fat percentage tends to be higher. But it doesn't imply, this simple measurement here does not imply a causal relationship. Now you may be able to hypothesize a causal relationship, and that's up to you, but ultimately this thing does not prove that causal relationship exists. All that does is say they appear together. That's a vital, important concept of correlation. The idea that correlation is not the same as causation, that's extremely important. All this says is that the two variables are linearly related, which means that they tend to appear together, and the shape of that appearance is on a straight line. And finally, as one variable goes up, the other variable seems to get higher as well. And that's all you can say based on our calculations.